Hey guys, this is 9.1 filing, chapter 9 after we did 2.4 direct variation. The bell ringer is just a review what you were supposed to pick up in 2.4. Remember, direct variation looks as such. So we say, okay, if we're going to solve for k, k is going to be equal to -4. So the equation we're going to actually graph here is -4x equal. So that intercepts at 0, 0. And then I'm going to run down 4 for every time I go over 1. And if I go backwards, obviously it's up 4 for every time I run back 1. I can do a better job. So let's see here. That's a little bit better. Now, so it says write an equation that relates x and y, then graph it. So there's my relation, and my graph is as follows. So it's the same deal here. They vary directly. K is going to be 2 here. So y equals 2x. Starting at 0, 0, I'm going to slope of 2. Okay, so if I'm going backwards, it looks like such. And then I'm just connecting these with a straight line. Equation, graphs. There's your warm-up, okay? Going down here, I'm going to write and use inverse variation, joint models. If you vary inversely, this basically means that y is going to equal k divided by x. That's what that means, okay? So every time you hear inversely, x is on bottom. So in number 1, we're going to write an equation that relates x and y such that x and y vary inversely and y equals 6 when x equals 2. So this means we're looking at the same equation as above. This time now, 6 equals k over 2. So k is going to be 12 when you multiply 2 out. So y will equal 12 over x. There's my equation. All right. And now the lovely word problems that everybody always loves. Again, okay, just read it the first time through before you start solving it. The time required to empty a tank varies inversely with the pumping rate. Right there is your equation. And it's going to take some practice till you get used to how that is supposed to be read and translated into an algebra problem. The rate of a certain pump is 70 gallons per minute. It takes 20 minutes to empty that tank. We're going to write a model of inverse variation for this situation to find out how long it would take to empty the tank if we got a pump whose speed was all the way up to 100 gallons per minute, and how that will make it shorter. So let's just start with the time required to empty a tank varies inversely with the pumping rate. So time equals k over, because it's inversely, with the pumping rate, which would be R. So when I set the first scenario up, this is my rate, this is my time. So I'm getting 20 minutes equals k over 7. Okay, and if you wanted to put units in here, it would be gallons per min, and this would be minutes. So when you multiply 70 gallons per minute out of there, and multiply this times 70 gallons per minute, okay, you can see the units minutes will cancel out because one's on top, one's on bottom, and 70 times 20 is basically 1420. Okay. So you're looking at a 1,400 gallon tank you're trying to empty here. Now, that means my equation will be time will equal 1,400 gallons divided by the rate, which is minutes per gallon. So we increase that to 100 gallons per minute. So that's going to look like time equals 1,400 gallons, stays the same, divided by 100 gallons per minute. So gallons will cancel out, okay? And basically 2 zeros cancel out. So we're looking at time of 14 minutes. So instead of taking 20 minutes to empty that tank, 14 minutes would be it. Where would you use this? Panama Canal is a huge one where they're actually doing that now. Rebuilding the canal down there in Panama. So if you're interested, look that up. Z varies jointly with x and y in the next one. This means basically the following. Z varies as equals with k and x and y. Jointly just means they're both on top, x and y are together. If you saw inversely, that one would be on bottom. And you'll see examples of that here in a second. So I'm going to shift my screen up. I think I'm going to shift my screen up. There it goes. All right, looking at 3. Z varies jointly with x and y. So that means z equals k times x times y. That's what this sentence is read as. Okay? Using given values to write an equation relating x, y, and z. Well, we got to solve for k here using these values that you see here. So 40 will equal k times 5 times 2. So 40 equals 10k. K is going to be 4. No surprises there, right? So I'm going to write my equation. It's 4xy equals z. And that's all you have to do for 3. All right, moving along here with number 4. The variable z varies directly with x and inversely with y. Okay, so let's make sense of this sentence here. Z varies, z equals directly with x. That means k and x are on top. Inversely with y puts y on bottom. Given the values, x is 3/4, 5/12, 6/25 for z, find the equation relating x and y. So we're solving for k. Don't let fractions throw you for a loop here. Okay, and x is 3/4. This is all divided by 5/12. Okay, so there's a lot of ways you could do this. Probably the easiest way for me to do it here with you is let's multiply that fraction out of the denominator so we don't have a fraction in a fraction. 5/12 divided by 5/12 is 1. So this gives me 3/4 times k equals 5 times 6, which is 30. Oh, well, let's cross cancel here. This is 1, this is 5, 6 is 1, 12 is 2. So 1 times 1 is 1, 2 times 5 is 10. So if you do 5/12 times 6/25, you should get 1/10. All right, let's get rid of 3/4. I'm going to choose to multiply by my reciprocal of that. This gives me 1k, and this will be 4/30, which then would be 2/15. So there's your k value. So the equation relating all this stuff, I'll put it in maroon, will be z equals 2/15 x over y. Okay, you can leave it like that if you did not want to leave it like that. Okay, if I wanted to simplify this a little bit more, that cancels out. So basically, if I really wanted to simplify this up and rewrite this so it's nice and neat, I'm looking at 2x over 15y. Okay. If you have a question with that, let me know. What I did down here is I multiplied by the reciprocal 1/y, so y divided by y is 1. So it's like dividing by 1, which means you don't have to write it anymore. 2 times x times 1 is 2x, 15 times y is 15y. So that's good to that. Right? So let's do some practice down here in 5 and 6. Going to keep moving the ball forward here. Okay? Let's start with number 5. The variables x and y vary inversely, so that means y equals k over x. Use the given values to write your equation, and then we're going to find y when x is 10. So there's 2 parts to this. First, we're going to find the equation, solve for k, find the equation, and then we're going to evaluate that equation when x is 10. So we're looking at 4 equals k divided by 3, so k can clearly be stated as 12. Here's my equation. 12 divided by x, there's my equation. Let's plug 10. So y will equal 12 divided by 10. Y will equal 6/5. So here's my equation. That's for part A. Part B, which I'm calling when I evaluate when x is 10. Let's go to the next guy. Let me change my color over here. Let's go, I guess, green. So this is still going to be the same equation, right? So 6 equals k over -8. Multiply -8 out of there. So this is -48 for k. So my equation here is -48 over x. Now let's evaluate this when x is 10. So this means I have -48 over 10, which we know is 4.8. Okay. You could leave it as a fraction as well, which I believe is -24 over 5. Right? So there's basically 5 and 6, and this was our second answer, B. writing equation for the given relationship. This looks something familiar with what you'll see on your test or quiz. V varies directly with U. So V equals KU. So K times U. Directly means it's on top. V varies inversely with U. So that means K divided by U. W varies, W equals jointly with T, U, and V. So everything's on top. So that means K times T times U times V. A little crowded there. Letter D, V varies inversely, so V equals inversely with the cube of U. So K over the cube of U. E, W equals directly with U and inversely with V. So K and U are on top, V would be on bottom. Right? So if you can get comfortable with that, life is good. Okay, you don't have to really remember a whole lot. All right, so let's go through our last 4 or 5 or 6 here, I should say, 6 problems. How whether x and y show direct variation, inverse variation, or neither. Okay, so first thing we're going to do is solve this for y. So I'm going to multiply 9 out. So y equals 9x. That would be direct. So there's number 1. Let's go through number 2. Okay? So this would be y equals half times x. There's nothing you have to do to solve for y there. That is direct variation. X is not on bottom, x is on top. That's what makes it direct. Here you go with 3. Y equals 0.1 divided by x. This is inverse variation because x is located on the bottom. And then here we go. This would be neither. That is not direct variation. This is a linear equation. Okay? So recognize that when you have plus or minus on the end here, all bets are off. That's not direct variation. Or inverse variation for that matter. Coming down to number 5. 5 times what is 15? 5 times 3. So that means 8 times 3 needs to be 24. 1.5 times 3. So is this direct variation? I would say yeah. Because if I write an equation for this, this would be y equals 3x. Coming over to 6. I would say, okay, let's set this up here. 3 times what is 5? Let's see, 5/3. If I do 5/3 times 5, that would be 25 over 3. So it can't be direct variation. So let's try setting this up as inverse variation, such as this. Y is 5, k, x is 3. So this one will be k is 15. So my equation, if this is going to be inverse variation, would be 15 over x. So if I put 3 in here, yeah, I get 5. If I put 5 in here, 15 divided by 5 is not going to be 21. So this is going to be neither direct or inverse. If you want to see the work for direct, this is what I would do. 5 equals 3x. You can see, sorry, k. So 5 over 3 is your k. So I would test 5/3 times x. Put 3 in here, you can see that's 5. If you put 5 in here, it's going to be 25 over 3. It's not 21. So it's not there. Okay? If you got to test your equations for yourself there. That's section not 2.4, but 9.1. All right? Should have a good foundation going into 9.2. I will see you guys soon. Take care, all right? Make good decisions.